you're given two functions, f of x equals ln of x plus 2, and g of x equals the linear function 4/3 times x. So the slope is 4/3. Y-intercept is at 0, 0. Here's a diagram or a graph of the two functions, and we want to find the area, a formula for the area of this green region. The difficult part of the problem is actually finding the points of intersection of these two curves. There's a few ways to do that. You could use Newton's method, which I'm going to show you a picture of that in the next board. If you visit this graph later, you can click on these links to see how Newton's method was used. On Desmos, you can do something tricky like this, or you can just click on this point and then add it to your left-hand side. And if you want to, call it point A and point B. But in order to find the area, we want to find a representation for the height of this rectangle if we're going to do it in terms of x, or for this red rectangle if we're going to do it in terms of y. Okay, so on board 2, these first two pictures are an example of finding the points of intersection using Newton's method. So we want to know what are the roots of this function right here. And Newton's method, that's Newton's method right there, where the starting value is 0.3, and that results in the 0.1697. Over here, I've labeled points A and B with those coordinates. The posted problem sent around to the nearest thousandth, so we could put a 7 here and a 2 there. But then the area of the region, in terms of x, is going to be the definite integral from a dot x, which is this 0.1697, to b dot x of the area of that rectangle, or the length of that rectangle rather, is the y coordinate at the top minus the y coordinate at the bottom. Okay, and here's actually an antiderivative for this function right here. And if I do big F of b dot x minus big F of a dot x, you can see I get the same area as I did here. To do it in terms of y, you have to solve these functions for x in terms of y. This is a horizontal distance right here, and we want to take the x coordinate at the right minus the x coordinate at the left. And here's how you solve for x for this first function, which is the tricky one. Subtract 2 from both sides, then realize that e to this exponent will give you that anti-logarithm. So there's x in terms of y. If you want to, you could rewrite it this way. Whoop. Okay, I'm going to stop recording there. Hopefully the whiteboard disconnected, but hopefully you still get to see all that.